What is machine learning? In this video, you will understand what machine learning is. You'll be able to explain it to others. You will have a clear mental image of how machine learning works, and you'll have an understanding of what the difference between programming, machine learning, and AI. All right, let's get into it. First, let's talk a little bit about regular programming. So here we have some data, and in regular programming, what we'd want to do is like put a line here, estimate that data. So what we would do is we'd take a look at this, and we would take a look at where this line begins, where this ends, where we just put it, and we calculate the slope and create a function to return that. And that would be just regular programming. We're creating this function to, after we look at this data, to estimate what the data is. But we can get the machine to do this for us using the data. Because maybe we didn't pick the best line. We want to get a really good line that fits that data, and we just kind of eyeballed it and we programmed it. So which of these lines would be the best? So we're going to use those x's and y's to make a function instead of us programming what that function is. And we're going to use these y's and these x's to do that. So in this function, f of x, we're trying to figure out what a good value of a is and what a good value of b is. Now, what we can do is we can go into, something like Excel or Sheets or something like that, create this graph, and then we can click on it and we can say, fit best line to the data. And that's what I did here. I used Google Sheets to create a line for this. And it said that the best value of A would be 0.6 and the best value of B would be 1.9. And it used the data to do that. Okay, well, it's a bit of a black box. I just click something in there. How could we do that? Well, one way we could do that, if we wanted to do that instead of just tell Sheets or Google or Excel to do that, is that using that data, those y's and x's, well, we could pick a random-ish a and b. We could calculate the error that we got using the function, and we just keep iterating until we have a low enough error. And we just update the a and b if it's better. So let's jump into some code and see what that looks like. So here's some code. On the left, we have the code in Python. On the right, we have the same code in JavaScript. So this is our data, our x's and our y's. And what we're going to do is we have this function to grade the x's and y's. So given some a and b, we're going to estimate what that value is, subtract it from y to find what the difference is, and then square that error. We want to really, big errors, when we square them, will become huge, and small errors when we square it, will hardly be anything. So we're really putting an emphasis on the bigger errors. So we calculate all the errors and we return them. And we do the exact same thing here in JavaScript. These two functions are the same. And then I'm going to get back to the sum change in a minute, but we start with sum A and sum B, just initialized, and with our initial error. And we're going to do exactly what we said. We're just going to start trying some new A's and B's. So some new A, some new B, with some change. So the change is just a random number from 0 to 1, and we subtract 5 so that it's from -5 to +5. And so we're just adding a little bit of change to A and B. We're grading what the new A and B is to find the new error. And if that error is less than our previous error, well, we're going to use that new A and B. And then every time this happens, we'll print out what our new A and B is. So let's run this program. Here's the Python, and there we go. It ran through. It found at first these different A's and B's, and it settled on this particular value. Let's run that in Node. And here we go. Very similarly, it just ran through and it found a whole bunch of A's and B's. And this was the best one that it found. And you can see that this value and this value are extremely close. So 0.605 and 1.84. And that's machine learning. It's using data like these y's and these x's to make a function like a times x plus b. That's really it. Machine learning versus programming. In classic programming, we make a function to create data. In machine learning, we use data to create a function. Hey, let's go over some terminology here. Because people use these fancy words in the industry, and we want to make sure that we understand them. So when we're talking about x's and y's, we're talking about the training set. And the function y equals a times x plus b, people call that the model. And the way that we grade our function in the industry, we call that the loss function. And finding a better a's and b's for that function, that's called optimization. Okay, let's just go over the model just a little bit more. Imagine we have this data instead, and this is our function. Return a times x plus b. Now, if we try to use this model, this function, and we try to use machine learning to fit this data, what we end up with is something like that. Well, because it's trying to put a line to something that's obviously not a line. If we change our model to be a bit better, if the function that we're trying to fit to use machine learning to find the values of A, B, and C, if that function represents the data, represents the reality better, then we'll get a much better fit. And so it's still up to the programmer, still up to us, the creators of the machine learning system, to create a good model. And the machine learning process just fits the values, the A, B's, and C's that we're looking for in our model, fits them by using the data. Okay, let's review where we are. Machine learning. So by now, you understand what machine learning is. You use data to create a function. And you can explain it to others by talking about fitting a graph, finding values of A and B by using data. And you have a clear mental image of how machine learning works. We pick some values, we calculate some error, we do an update if our values are better, and we repeat. I just want to say that this isn't the only way of how machine learning works, and it certainly isn't the way that something like Tensorflow or Torch uses to do machine learning. It doesn't pick values first, then calculate error, then update. Instead, we calculate error, and in the calculation of the error, then we can calculate something called gradient descent, which effectively picks our values, and then we do our update. So the order is a little bit different, but we definitely repeat that a lot. So we talked about programming versus machine learning. let's now take a look at machine learning versus artificial intelligence. AI versus ML. Artificial intelligence is a program that seems to do an intelligent job. That's it. That's when some program seems to do an intelligent job, we can call that artificial intelligence. An example of that is a classic checkers. So for a classic checkers AI, we use a program like an algorithm called Minimax, for example, or Alpha Beta. And there's lots of others, lots of other types of approaches to this, where what we do is we take a look at, for a particular move, in this case, black just made a move. White has an option of looking at, in this case, 3 different moves. And being white's turn, the AI for white will take a look at each of these different moves and then explore what all the counter moves are to that. And then explore all the counter moves to that, and explore all the counter moves to all of those moves, trying to find what move would optimize its position on the board. Now, how does it tell how to optimize the board? Well, someone creates some scoring function. So in this case, this scoring function might be the probability of winning, or the amount of the chance of taking another piece. So let's say it's the chance of taking another piece. So black here, in its last move, it has a 40% chance of taking a piece and being ahead in the game. So white has an option of 3 different moves. One where it has a 20% chance of taking a piece and getting ahead, a 30% chance, and an 80% chance. And what Minimax, the Minimax artificial intelligence program algorithm does is it says, okay, well, let's explore each of the possible counter moves and the counter moves to that. So in this diagram, it explored just one of those off of where it had an 80% chance. And it sees that black has a 60% chance, 50% chance, and a 30% chance with different types of moves to counter that move. And using this type of algorithm, I'm going into the details of Minimax's beyond this this video, but going through that algorithm, the AI can actually perform fairly well. Someone creates the scoring function, and the AI is just going through repeatedly scoring all of the boards and all of the moves. For a modern checkers machine learning, the machine learning creates the scoring function by playing lots of games, collecting the data, and figuring out what a good function is. It turns out probability of taking a next piece, or percentage of the board, percentage of all pieces that you own, is not really a good scoring function. A much better scoring function is how many liberties you have, how many actions you can take compared to how many actions your opponent can take. But there may be better ones. And so if the machine learning can just play a lot of games, collect a lot of data, and create some function, as I've written ax plus b, obviously the function would be a lot more complicated than that, then it would be able to play a really good game. So when someone says, something is AI, what they're saying is that it's a program that seems to act intelligently. That's it. If we make a decision tree, if we make, if-else statement in our program that does something that seems intelligent, then we would call that AI. If what we're doing is we're creating a function from data, we would call that machine learning. And the two are not necessarily different. Something that creates a function from data and learns from that data to do a function well, that seems like it's acting intelligently. So in modern speak, we talk of machine learning as a subset of artificial intelligence. There's certainly a lot of overlap between the two. Now you can explain machine learning. I'm really happy that you watched this video, and I hope to see you in the next one. Cheers.